Module 5, Advanced Topics. Performance tuning, optimizing queries and tuning server settings. Performance tuning in PostgreSQL involves optimizing queries and tuning server settings to improve the overall performance and efficiency of the database system. Here are some key areas to consider. 1. Query optimization. PostgreSQL provides a powerful query planner and optimizer that can optimize queries for execution. However, there are several techniques you can use to optimize queries further, such as optimizing joins, reducing the use of subqueries, avoiding unnecessary data retrieval, using appropriate indexing, and optimizing aggregate functions. Understanding and analyzing query plans, using explain and analyze commands, and using tools such as pg_stat_statements or pgbadger can help identify performance bottlenecks in queries and optimize them for better performance. 2. Server settings tuning. PostgreSQL provides a wide range of configuration parameters that control the behavior and performance of the database system. Tuning these settings can greatly impact the performance of the database. Some important settings to consider include shared_buffers, work_mem, effective_cache_size, max_connections, and maintenance_work_mem, among others. Properly configuring these settings based on the available system resources, workload characteristics, and hardware specifications can greatly improve the overall performance of PostgreSQL. 3. Hardware considerations. The performance of PostgreSQL can also be influenced by the underlying hardware infrastructure. Factors such as CPU, RAM, storage, disk I/O, and network can impact the performance of the database system. Ensuring that the hardware resources are adequate and properly configured, such as using fast storage and optimizing disk I/O, can have a significant impact on the performance of PostgreSQL. 4. Regular maintenance. Regular maintenance tasks, such as vacuuming, analyzing, and reindexing, are important for keeping the PostgreSQL database healthy and performing optimally. Vacuuming helps reclaim storage space and optimize the performance of the database. Analyzing helps update statistics for the query planner, and reindexing helps optimize index performance. Regularly scheduling and performing these maintenance tasks can help ensure optimal performance of PostgreSQL. Performance tuning in PostgreSQL is an ongoing process that requires careful analysis, understanding of the system, workload characteristics, and appropriate configuration adjustments. It is important to thoroughly test and measure the impact of any changes made to ensure they have the desired effect on the performance of the PostgreSQL database. Extensions and foreign data wrappers. Extensions and foreign data wrappers (FDWs) are advanced features in PostgreSQL that provide additional functionality and capabilities beyond the core database system. Here's an overview of these concepts. 1. Extensions. Extensions are add-on modules in PostgreSQL that provide additional features and functionality. They are designed to extend the core capabilities of PostgreSQL and can be used to add support for specific data types, operators, functions, or other advanced features. PostgreSQL comes with several built-in extensions, such as Store, for key-value storage, PG_TRGM, for trigram matching, and many more. Extensions can be installed, updated, and managed using SQL commands or through tools like the PostgreSQL Extension Network, PGXN, and the PostgreSQL Extension Packaging Infrastructure, PGXPI. 2. Foreign data wrappers, FDWs. FDWs are PostgreSQL features that allow data stored in external data sources to be accessed and queried as if they were regular tables within PostgreSQL. FDWs provide a way to define and configure external data sources, such as other databases, file systems, web services, or custom data sources, as virtual tables in PostgreSQL. Queries can be executed against these virtual tables, and the results are fetched from the external data source in real time. FDWs provide a powerful way to integrate and query data from diverse sources within PostgreSQL, enabling data integration and consolidation scenarios. FDWs are implemented as extensions in PostgreSQL, and various FDWs are available as open source or commercial options, including Postgres_FDW, for PostgreSQL to PostgreSQL communication, DBLink, for general-purpose database communication, file_FDW, for reading data from files, and many others. FDWs can be created, configured, and used through SQL commands or graphical tools, and they offer a flexible and powerful way to interact with external data sources within PostgreSQL. Extensions and FDWs provide advanced capabilities in PostgreSQL, allowing users to extend the functionality of the database system and integrate with external data sources. They can be used to enhance the performance, functionality, and versatility of PostgreSQL to meet specific requirements and use cases. However, they should be used with caution, and proper security measures should be implemented to protect against potential risks and vulnerabilities associated with external data sources and custom functionality.
Thanks for watching. For more information, like, comment, and subscribe our channel.